Hey, welcome back to another Algebra 1 lesson. Today we're going to talk about the intercepts of graph. If you think about the word intercept and what that means, I'm sure you've heard of football players during the football game, he intercepted the ball. I always think about that ball as moving in a straight line. It moves from one player to the other player. But what happens when somebody intercepts the ball? Well, they get in between this player and that player, and they jump up and they grab the ball, right? They intercepted the ball. So when I think about that in terms of graphically speaking, I imagine my graph, here's my line. Well, let's draw my graph first. Well, that was a terrible graph, but that's okay. You get the idea. So I'm drawing my line here, and here's player A, here's player B. He's going to throw the ball over here. This is the intentional plan for the ball to go from point A to point B. But on the way, somebody jumps up and grabs it right here. They intercepted the ball. So this interception, or this intercept in this case, is where the line crosses the y-axis. So if I'm looking at this, 1, 2, 3, 4, it looks like my graph crosses the y-axis at a positive 4. So the y-intercept would be 4. So it's that point there in between, one end of the line and the other end of the line, or, lines go on forever and ever, so there's no end. But it's an intercept is a place in between 2 points on the graph where that line crosses the y-axis or where it crosses the x-axis, depending on which one we're looking at. So that's just kind of an overview of what we're going to talk about in this, but it's important for you to look at the vocabulary. So in today's vocabulary, we're going to cover x-intercept, of course, y-intercept, if the line is positive, if it is negative, if there's a root, and if there is a zero. And all of these all kind of tie in together. We're looking at positive functions, and that's when the graph is above the x-axis. We're looking at the root, which is a solution to an equation. And when we look at the zero, that is an x-intercept of the graph. So this might not make a whole lot of sense right now, but as we progress through this, you'll start to understand this a little better. So the intercepts of graphs are points where the graph intersects an axis. It's where it crosses an axis. So looking here, we have several different intercepts. We've got the x-intercept here at -4, -2, and whatever this point is, somewhere between 0 and 1. We also have y-intercepts. My y-intercept is down here at -3. It's where this line, this curve, this graph crosses the y-axis is the y-intercept. Where is my graph positive? Well, everywhere that it's above the x-axis, what is that? Everywhere it's above the x-axis is where my graph is positive, and everywhere that it's below that x-axis, it is considered to be negative. All right, so let's look at an example here. It says the intercepts of graphs of a linear function. It wants us to identify, if you're following along in your student workbook, this is on page 167. It wants us to identify the x-intercept, the y-intercept, and tell where the function is positive and where the function is negative. So again, x-intercept is where it crosses this x-axis. This down here, I'm going to highlight this if I can, is my x-axis. So where does my line cross the x-axis? It crosses right here at this point, which is 1, 2, 3, a positive 3. So my x-intercept then is positive 3. So if we were to write the coordinates of this point, it would be 3, 0. Okay, well, what is the y-intercept? The y-intercept is where it crosses the y-axis. So if we look right here at this, it crosses at 1, 2, 3, 4, 5, 6. It's tempting to put 6, 0, but it's not 6, 0, it's 0, 6, because my x always comes first when I'm listing an ordered pair, and then the y value. My x is at 0, and then I come up to 6, so the y is 6. Over here, I came over 3. The x coordinate is at 3. I went up or down 0, so my y coordinate is 0. So we have our x-intercept, we have our y-intercept. The other thing it asks is, where is it positive? Well, if we're looking back at this function, it is positive everywhere where the graph is above the x-axis. So let's look at this. My graph is always going to be above the x-axis from here on up. It goes up forever and ever and ever. That's above the x-axis. So let's look at what this x value is. That x value is 3. So for all values of x that are greater than 3, nope, not greater than. Look, it's going this direction, right? My x's are going this direction as my y's are going up. So it's all of my x values that are less than 3, or less than 3 is where my function is positive. So let's click on this. Where is it positive? For all values of x less than 3. Where is it negative? Well, it's going to be negative everywhere below this. So it's negative for all values of x greater than 3. Notice neither one of those included 3, because 0 is neither negative nor positive. It's just 0. So we didn't want to say that it was equal to 3. We wanted to say it was positive when it's less than 3. And it doesn't mean that the numbers are positive. Obviously, x is not, numbers less than 3 are not all positive. But we're looking at where the graph is positive. Where is this line staying above the x-axis? And it's for all of the values of x that are less than 3. Where is this graph going down below the x-axis? It's everywhere where the values of x are greater than 3. So it's a little bit confusing because we like to think, x is less than 3. Well, x is less than 3 would be 2, 1, 0, -1, and we start getting into negative numbers, so it doesn't make sense that it's positive in our minds with its negative values. But look at where the y value is when it's at -1. It's still way up here in the positive area. So my graph is said to be positive everywhere it's above the x-axis. And so for all values of x that are less than 3, my graph is above the x-axis, and therefore it's positive. Everywhere that it is below the x-axis is where it's said to be a negative function, and we can see that it's below for all the values of x that are greater than 3. All right, so let's try example 2. Intercepts of the graph of a nonlinear function. So that one was just a straight line, and we were looking at the intercepts. This one is a nonlinear function, so it's not a line, it's a curve. This is called a parabola. So with our parabola, we want to look at what are the intercepts. Where does it cross the x-axis? Where does it cross the y-axis? So our x-intercepts, there are 2 of them, are at -4, 0, and 3, 0. Remember, list the x-coordinate first, then the y. Our y-intercept is down here at 0, -12. My x value is 0. My y value is -12. Where is the graph positive? Well, it's positive for all values of x that are greater than 3, but it's also positive for all values of x that are less than -4. So we've got to write that out where we say we've got the 2 cases. It's where it's less than -4 for this end down here, or where it's greater than 3 for this end over here. And where is it negative? Everywhere in between. It's negative for all the values of x in between -4 and 3. Okay, so example 3, finding the intercepts from a graph. Sports. Everybody loves sports, right? I'm not necessarily the most athletic person, but I love sports. I love watching football. I love watching basketball. It's especially fun to watch you guys play at high school. I love going to high school games to see you guys in your element. So anyway, that's a little side note. I love sports. I like watching it. The graph shows the height of a ball for each second x that it is airborne. Use the graph to estimate the x and y intercepts of the function. So we can automatically see the y-intercept is right here at 4. So the height of the ball is my y-intercept. The height of the ball is 4 feet. And my x-intercept is at 9 seconds. So let's think about what this means. When I throw the ball, I must be throwing it from, I'm assuming they're throwing the ball. I don't know. I'm throwing it from 4 feet in the air. When I stand up, I'm 5 foot 3 inches. So obviously I'm not holding it above my head. I must be holding it down here somewhere. Maybe it's basketball and I'm throwing it here. I'm holding it at 4 feet, passing it to another player. So the ball is 4 feet in the air when I pass it. Maybe I don't pass it straight. I'm trying to get over another player's head, so I pass it up, and the ball reaches a height of 9 feet. But after 9 seconds, it hits the floor. Instead of the player catching it, it hits the floor. And the reason I know this is because the height of the ball is 0 feet in the air. So after 9 seconds, it is 0 feet in the air. Maybe we're talking about pitching the baseball. I don't know. I don't know what they're talking about. It doesn't necessarily say what sport we're talking about. But we know that the x-intercept is 9. That's this point right here, meaning that the ball will be hitting the ground after 9 seconds. The y-intercept is 4, meaning that at time 0, when the ball was first thrown, it was thrown from a height of 4 feet. And of course, our function here is always positive. The ball's not going to go negative feet down into the ground, and we're not going to throw it negative seconds. So the entire function is a positive function because in the real world, it wouldn't make sense to look at the negatives. There are a lot of things that doesn't make sense to look at the negative. Anytime you're talking about time, it doesn't really make sense to look at negative values. If you recall in your previous test, you had a problem that said, when will the two cars be the same distance away from Seattle? I think was the way the question was worded. Well, when you set the two functions equal to each other, it came out to a negative time. At negative 10 hours, they would have been equal distance away from each other. Well, that doesn't make any sense for cars to travel negative 10 hours, so we knew that there was no solution to that real world problem. All right, so finding the intercepts from a table. Now, I want you to imagine in your mind real quick the graph. Just kind of close your eyes and picture the graph, or instead of making you close your eyes, let me draw it for you. Here's the graph. And we know that the x and y intercepts are where one of the values is equal to 0. So for my y-intercept, my x is always 0, and then whatever that value is of y. For my x-intercept, we always have the x value, and the y is equal to 0. So keeping that in mind, visualizing that graph, think about looking at a table. It says finding the intercepts given the table. I don't want to graph this to try to find them. So I'm going to think about the fact that I know that it crosses the y-axis when x is 0. So right here's an intercept. And I know that it crosses the x-axis when y is 0. So here is the x-intercept. And let's think about what that means. Time is in days and the balance is in money, of course. So at 0 days, she has $150. It says each day she spends $3.75 on her lunch. That means on the first day, her parents must have deposited $150 into her account. And after 40 days of spending $3.75 each day, she now has a balance of $0 in her account. So that's what the X and Y intercepts mean. All right, so let's tap on each button. It says to find the X and Y intercepts of the graph of the function. So again, when x is 0, y is 150, so our y-intercept is 150. The x-intercept is x is 40 when y is 0, so the x-intercept is 40. And what this means in terms of the problem is on day 0, she had $150, and after 40 days, she had $0. Describe what the intercepts mean. We just did that, so that's already taken care of. And I'm going to stop the video here for this video, and we'll pick up with this learning for the next video.